Welcome to this video lecture on scientific research in information systems. This video lecture is about research design. It will cover induction, deduction, and abduction as logical reasoning skills that feature in research designs. It will discuss research strategies, namely exploration, rationalization, validation, that feature in research designs. It will discuss the different choices one has to make when building a research design, different research methodologies that could feature in research designs, and discuss the role of literature in the research design process. The main reading for this video lecture is Chapter 3, Planning a Research, from the book Scientific Research in Information Systems, a Beginner's Guide, that is available from Springer in its second edition in 2021 as a hard copy, soft copy, ebook, or most universities provide access to PDF copies of the individual chapters through Springer link. A URL is provided below. Research design is the process that we undergo to figure out how a study can answer a research question. Once a research question is specified, that's the next challenge, to craft a plan of action to answer the research question. And that is exactly what's called the research design. So it is a blueprint for the collection, measurement, analysis of data suited to answer the research question. And as such, it usually involves a combination of different reasoning skills, these being induction, deduction, and or abduction. These reasoning skills feature in different strategies, namely exploration, rationalization, validation, who could either be the focus or appear in combination in different research designs. We start by explaining induction, deduction, and abduction. Induction is a form of logical reasoning that involves inferring a general conclusion from a set of specific facts of observation. We are moving from observing particulars and trying to derive more general premises from these. So we use it to develop and formulate tentative hypotheses and propositions that declare general conclusions or theories based on a limited set of observations. So we do use it to infer theoretical concepts or patterns from observed data or known facts, and that way generate new knowledge by proceeding from particulars to generalities. As an example, consider that we can make observations about all life forms on the planet Earth, and all those that we have seen, and it could be millions, depend on liquid water to exist. From there, we can offer the induction that all life forms, including those that we have never seen or that we don't even know yet, will depend on liquid water to exist. The problem with induction is that the inductive argument itself can never be proven or justified through the induction. And moreover, inductive arguments can be weak or strong. The induction, I always hang pictures on nails, and therefore all pictures everywhere must always hang from nails, is a weak induction, probably because the observation is too limited or the generalization is too broad. Induction offers a useful pathway and a very well accepted pathway for constructing new theoretical explanation or hypotheses, because these conclusions are often based on educated predictions because we have some limited set of observations. So when I study a phenomenon in a limited set of cases, and I always in these sets of cases found a particular relationship or pattern to be at work, then I can develop the tentative proposition that this pattern Z is related to the phenomenon X in general in this or that way. An opposite so to speak, reasoning strategy is called deduction. That's a form of logical reasoning that involves deriving arguments as logical consequences of a set of more general promises as predictions about a set of observations. So we deduce a prediction as a conclusion about a specific instance from a general premise. This is we use deduction to develop predictions, expectations in the form of hypotheses or propositions. And in so doing, this is probably the most common approach to science. It's called the hypothetical deductive model. The theory is treated as a premise, and we derive some not so obvious conclusions as hypotheses that offer our predictions about what is likely to occur. If this and this is true, then this and this should happen. And these hypotheses are then tested and revised if necessary by comparing it to empirical data in experiments or anywhere else. As an example, if we take the premise that all men are mortal and we observe that Socrates is a man, we can deduce that Socrates must be immortal. The problem with deduction is what is called soundness and validity. We can proceed in deduction logically sound, but still end up with invalid deduction, namely if the premise is incorrect. For example, if we say only quarterbacks eat steak and John eats a steak, therefore John must be a quarterback, this is logically correct, but still invalid because the premise, only quarterbacks eat steak, is wrong. Induction and deduction are both important to many scientific processes. Um, what is important to realize that one is not better than the others. They both have their own advantages and disadvantages, and neither is sufficient or complete. And a third accepted way of reasoning is what is called abduction, the process of making sense of an observation by drawing inferences about the most possible or most likely explanation. Now, what is important is that abduction is not a logical is not a process of logical inference or deduction. Instead, it's more like a trial error set for a satisfactory explanation about an observation after the fact. So we can call it educated informed guessing. We observe something and then we ask ourselves, what is the most likely explanation for what I just observed? And in so doing, it is a creative process more so than a logical process. It is an operation geared towards the creative discovery of entirely new ideas without being bounded by logical modes of thinking through justification or formal inference. Here's an example that shows you how you can reason about this similar set of phenomena in very different ways. And the phenomena here is beans, and they have a particular color, and they are in a bag or near a bag. Yeah, so beans in a bag. In induction, we would move as follow. We could make an observations like this set of beans here are from these particular bags, and the beans are all white, and then derive at the induction that all the beans from the bag are white, including those that we haven't seen. In deduction, we would move from a premise to an observation. The premise might be that all the beans in the bag are white. And then we predict basically that any beans taken from the bag must be white. Yeah, so we move to an observation, a set of beans from the bag, and deduce that the beans must be white, and that we could then test by looking at the beans. In abduction, we could have a rule such as the beans from the bag are white, and we could have an observation. There's a bunch of beans, and they are white, and they're near the bag, and therefore the most likely and most possible explanation is that the beans are probably from the bag. So I'm not arguing that these are good or valid scientific explanations here, but hopefully you can see how these forms of reasoning proceed in quite different ways. Why is this important? It's important because good research involves different strategies, namely exploration, rationalization, validation, and they involve induction, deduction, and abduction to a different extent. In exploration, very often we use inductive reasoning strategies. We explore a phenomena and then maybe develop patterns or more general observations from the specific facts. In rationalization, we very often proceed abductively in that we search in rationalization for most likely or most plausible explanations. Validation, on the other hand, very often involves deduction, namely the development or derivation of a way of testing the predictions of a theory by comparing it against observation or other types of data. So exploration is the systematic discovery of things or phenomena. Rationalization is a sense-making process or a search for an explanation for the puzzle or problem. And validation is subjecting an emerging or existing theory to rigorous examination and testing. And now in research design, what we usually do is we can build research designs that are focused on either one end of this triangle or on the relationships. So the emphasis of any one study can be on exploration, rationalization, or validation, or some combination of them. So, for example, there are studies that explore and rationalize. So they study a new phenomenon and offer a first theory about it. There are studies that are only about validation. They take some theory presented by someone else and test it through experiments. Or sometimes we have studies that validate and explore. Yeah, arrow 5 here in my diagram. So that means they subject a theory to a test, discover that the theory is at least partially incorrect or incomplete, and then explore likely alternative explanations. One other important note is that the combination of all these aspects, so all the ends and all the links, what is here I denoted as point 7, is typically only achievable through research programs, which are logical sequences of multiple individual studies. Yeah, so a set of studies together can probably achieve all of that. What is important here is that the choice of emphasis in a research design is, of course, geared by your interests, where you want to contribute and how, and the availability of data to support exploration, validation, or rationalization. But it's also influenced by factors that are not in your own control, but rather given in the domain or in your field. So one of them is the maturity of the field with regards to phenomena. If you take a new and emergent phenomenon, say ChatGPT, then very often in the beginning, much of the research is focused on exploration. We don't know, so let's go find out, describe, and explore. Um, for example, with ChatGPT, we are not yet at the rationalization stage where we have a lot of theories available that would explain how and why ChatGPT would produce the type of consequences it does. Once we have that, we would naturally gravitate towards validation, that more and more research efforts are spent on being testing these theories and testing new predictions and so forth. Conversely, if you study a field or phenomenon that has been studied for a long time, say adoption of new technologies in the firm, that is something that has been studied for 30, 40 years, the field would likely see very few new exploration. We've explored it for a while, and we do have a lot of rationalizations, different theories available to explain it. So naturally, the starting point would be some combination of validation, perhaps with exploration. Finally, different fields have an emphasis on different research methods, and different research methods support either one of these different spectrums, usually not all of them. So, for example, in psychology, a lot of emphasis is given on behavioral experiments, and behavioral experiments are very good for validation, not very good for exploration. In IS, in information systems, we have the fortunate situation that it's a pluralistic field where many, many different methods are accepted, meaning that you can basically freely choose between exploration, rationalization, and validation. And to illustrate that, I brought an example from my own PhD research program many years ago, which was around process modeling grammars. And my research design in this program, in this PhD program, featured many different elements. So, for example, this particular study was an exploration study where I described what companies were doing with this particular grammar and the standard, and just seeing what sort of issues they ran into. This is not a rationalization study. There's no validation, purely exploration. Study what is now here number 3, based on the diagram, the triangle diagram that I showed you above. This is a validation study. This takes an existing theory and subjects it to a test using new collected data. Number 5 here is a study that moves between validation and exploration. This is a study that took as a starting point a theory, subjected it to empirical test, and explored alternative explanation, because the testing showed that not all of the predictions of the theory were in fact faithful. They were not correct, so to speak. And finally, and as an example for the research program, this entire body of work, the different studies and so forth, actually at some stage were published as a book. And this book, in a way, describes the entire research program throughout the different stages and the different types of studies.